Turbulence. It is all around us, involved in every part of our life, yet it often goes unnoticed. Everywhere from stirring a cup of coffee to blowing out a candle and sweeping dust with a broom. But what is it? How do scientists define turbulence?
Turbulence is one of the only unsolved problems in classical physics, and scientists still know very little about it. But more or less, turbulence is a complex motion of a fluid resulting from currents and subcurrents flowing in different directions, causing disorder. One important characteristic is vorticity, where a fluid is distributing continuously but irregularly in every direction, such as smoke coming out from a chimney. Also important to note, turbulent effects are irreproducible in relative detail, meaning as careful as you are in recreating exact initial conditions, the fluid will never repeat its movements.
There have been countless attempts at trying to understand the phenomena which is turbulence. One being Osborne Reynolds, who in the 1890s published a theory about turbulent flow that is still in use today. Much of his work involved conditions of fluids under which they transition to turbulent flow. His theory was that a ratio of the inertial forces of fluid and to its viscous forces could predict turbulent flow. This ratio came to be known as the Reynolds number.
Claude-Louis Navier and Georges Gabriel Stokes came up with the next notable theory. They came up with a series of equations to describe fundamental variables of a fluid such as momentum, convection, compression, pressure, among others. The only problem with their equations is that they contain too many variables to be solved analytically, by hand. This means the only way to solve and manipulate these equations is by using supercomputers. The supercomputer tests a series of numbers in the equation simultaneously until it finds the correct variables. The results from this supercomputer can be amalgamated digitally onto a screen to model turbulent flow in a fluid under certain conditions. Now here's a take on how the equations can be modeled and manipulated to show the flow of air around a building.